And we're back. In this problem, we're going to work a vector application problem. So we have a 5-pound force and a 7-pound force, and they're acting on an object at the same time, simultaneously. The angle between the two forces is 110 degrees. We want to find the magnitude and the direction of the resultant force. All right, so all we know is we have two forces acting on an object. And most of us think, all right, well, this is easy for me to think of as a push. So two forces pushing on the object. But I know I've mentioned this in a previous video. When we start to think about forces acting on an object, I encourage you to think about them as a pull. So I have a 5-pound force, and I'm going to draw my 7-pound force just a little bit longer. We have 5 and 7 pounds, and we know the angle between these two forces is 110 degrees. We want to find the magnitude and direction of the resultant. Well, you want to keep in mind that the resultant is formed or found by drawing this parallelogram. So the resultant is going to go from that origin where both of the forces are acting and cross through the diagonal. So this would be 5 plus 7 versus 7 plus 5. And addition is commutative, so we can do it either way. So we want to find the length of that purple vector that I drew, our resultant, as well as the angle it creates with each of these forces. In order for us to do this, I encourage you, as always, to, once you have that drawn, pull a triangle out. So I'm looking at this triangle up here at the top, this guy. So I'm extrapolating this triangle so we can think about it over here on the side. I'm going to call this side my 5, and then this top piece will be 7. Over here, my resultant, I do not know that yet. I will call that R. And I know that this whole angle is 110. But one thing I do not know is what either of these two little angles are. This resultant vector does not bisect those angles. What I do know is that this angle and this angle of my parallelogram are 110. And I also know that these same side interior angles are going to be supplementary. So that means this angle up here in the top corner, this guy is 70 degrees. Again, now I have a side included angle side, side angle side triangle, and side angle side means that we are going to use the law of cosines. All right, so let's label our triangle. So I already have that little r there. I'm going to call this big R, and then I'll just call this angle A, which makes 7 be little a, and my other angle will be D, which makes 5 little d. So now we have triangle RAD. That's super rad. All right. How should we set this up? I'm going to ask you to pause right now, try and set it up on your paper and work it out. I'm going to do my workout on the paper. First, I wrote out my law of cosines pattern that I'm going to use. Keep in mind, I'm building this off of the rules that we initially wrote a couple sections ago. We said that a squared equals b squared plus c squared minus 2bc times the cosine of angle A. So that's our pattern, and I'm just rewriting it to use the new variables that we're dealing with in this problem and in a method or a way so that I can just kind of plug and chug with my calculator. So I've written the rest of the calculations out here. So pause, make sure you can get these numbers in your calculator. I get my R is 7.6. And of course, when I do my cosine inverse and I use that 7.6 in my cosine inverse, I'm using an exact value. I'm either storing it or I'm using the answer button. If you're still struggling with that, send me an email. I'll see if I can figure out another way to help you understand how to use your calculator better because it's really your friend and you're always going to have it on your test. Anyhow, we get the angle for A is 63.31 degrees. So the resultant is 7.6 pounds of force. So 7.6 pounds. And we know that angle A is this piece right here. So this angle or this piece is 63.31. So 63.31 degrees. We make a 63.31 degree angle with the 5-pound force. So then what kind of angle do we make with the larger 7-pound force? That would be the 63.31 minus, I would subtract that from 110. So 110 minus that 63 gives me 46.69. So 46.69 degree angle with the 7-pound force. So that got a little jumbled here at the end because I'm just trying to cram it in. But the magnitude of the force, these two forces acting together, 5 and 7, create a 5.6 pound force. And it's not really that much greater because they're not really acting in a similar direction. So we're not like doubling that force impact, you know? And then we have two angles. This angle right here, we make a 63.31 degree angle with the 5-pound force, as well as a 46.69 degree angle with the 7-pound force. And this doesn't specify, but you will notice on your homework, it'll say what's the angle that the resultant makes with the larger, the smaller force or specific force. As always, email me with any comments, questions, or concerns.